So okay, now we are going to learn, we're going to see the better solution for finding the number that appears once and other appears twice, right? Let's try to do this. So here we have an array. So let us try to analyze how we are going to do, how we are going to find out the better solution. So okay, let's just try to analyze how I'm going to do this. I'm going to use hashing. I'm going to achieve this using hashing, right? Okay. Let's try to see what we have here. I'm going to take a hash of size. What is the maximum element that we have given here? This is the maximum element, right? This is the max element is 4. So I'm going to define the hash array as max element plus 1. So this will be my hash array, right? I say it is 4, right? 5, 4, 5, 0, 1, 2, 3, 4. Yes. Okay. Here we got, it is probably initialized with zeros, all zeros. Hash is initialized probably with all zeros, right? I say, I'll go to 1. I'll go to 1. Yes, this is 1. I'll go to 1. Then again it will become 1. This is 2. I'll go to 2. This is 1 time. I'll go to 3. This is 1. I'll go to 3. This is 1. This is 2. I'll go to 4. This is 1. I'll go to 4. This is 2. Right? So, so what is this? This is only appear once, right? This is only appear once. So this is my answer. So this is my answer, right? 2 is my answer, which appears only once. I'm gonna do. I'm gonna say maximum. What I'll say here is maximum element is equals to array of 0, because maximum element is equals to array of 0. Then I say for loop I to 0, I to less than n, I will increment. Then I say, so okay. So then I say maxi is equals to max of maxi comma array of I, right? This will find me the maximum element. So now I'm going to define a hash. I'll define a hash which is maxi, right? It will probably initialize with 0, right? This is my hash array. Okay. So what I say is I'll write a loop for I equals 0, I to n, and I will increment. Then I say hash, then I say, hash of array of I increment. So it will find me the single element. So it is going to find me the element that is repeated once, right? So it is going to find that this loop, and I'm going to return the single element, the number that is the number that is repeat once. I'm going to return that. For that I say I equals 0, I to n, right? I to n, and I will increment, and I say hash, and I write a condition if hash array, when array of I hash array of I will become, when hash array of I will become 1, then return array of I. Then you should return the array of I. That's it. Simple. So when the element will become once the element, only once the element is only repeat only once, only repeated once. When we do this hash, then the array will, then it is going to return that element that repeated once. Let's try to get the time complexity for this. For this, the time complexity will be big of n, and for this loop, the time complexity will be big of n, and also for this loop, the time complexity will be big of n. So the time complexity will be big of 3n, and the space complexity will be big of max c, because it's depend on input, right? Which need to tell the integer. So that's depend on the input max c, right? Okay. What if all the given numbers are zero? What if all the given numbers are zero? All the given numbers in an array will be negative, will be negative, right? Will be negatives. If it be like 10 to the power of 9, 10 to the power of 15, like that. So these are the negative numbers, right? So for that, we're not going to use a we're not going to use hashing. So we are going to use a map data structure. What data structure we're going to use? We're going to use a map data structure. So here, if there is an array, I'm going to take this array and I say array contains 1 comma 1, 2 comma 3 comma 3, 4 comma 4, I say 8 comma 8, right? Let's try to take this array. I say 1 appears twice, 2 appears once, 3 appears twice, 3 appears twice, 8 appears twice, right? Okay. So okay, let's try to take, this is a map data structure, right? So this is the map data structure. So I'm going to take a long 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 data types. If it will be 10 to the power of 9, 10 to the power of 12, so that I'm going to take long data types, and I say these are the keys. So these are the keys, right? These are the keys, right? These all are the keys here, right? Okay. And I say what I'm going to do is I'm going to write a loop that will iterate up to n, and I say map, then I say map of array of I will just will increment, right? Okay. So this is going to increment. So I'm going to write a loop for iterate in the map. Then it will be like if iteration second is equals to 1, then I say return iteration first, right? Return that first. So let us try to analyze the time complexity for this. So for this, the time complexity will be n log of m, n log of m for the ordered map. So this is the time complexity for the ordered map. For the unordered map, the time complexity will be for an unordered map, the time complexity will be big of n, and for the worst case, it will be like big of n square for the worst case, right? Okay, for the worst case. So let us try to analyze the time complexity for this loop, that is n by big O of n by 2 plus 1. Why n by 2 plus 1? Why we are taking n by 2 plus 1 elements? It's like we have stored only 4 here, right? What we have stored? 1, 2, 3, 8. We have only stored 4 elements of the array because the size of the array was 7. The size of the array was 7, and we have stored only 4. For that, the time complexity is n by 2 plus 1, right? Okay. No, the one guy who is appearing once is 2, right? This one. So, and what is this M? M is the size of the map. What is this M? M is the size of the map. Size of the map, right? This is the size of the map. And what will be the time complexity then? That the time complexity will be big O of n log m plus big O of n divided n by 2 plus 1, right? But then what will be the space complexity? Space complexity will be big O of n by 2 plus 1, right? This we use for the map data structure. This we use for the map data structure. So this is time complexity and space complexity for the brute force, for the better solution. This be the for the map if the given numbers are negative, right? If the given numbers are negative, we are going to use this thing. So let us try to look the optimal solution. Optimal solution. So okay, let us try to learn the optimal solution for this. So for this, I'm going to use XOR. If I say this is the array, right? So this is the array 1s or 1, 2s or 2, 2s or 3, 3s or 3, and 3s or 8, 8s or 8. Then what will it become? It becomes 0. 1s or 1 becomes 0. 2s or 3s or 3 becomes 0. 8s or 8 becomes 0. Then zeros or 2 will become 2. So this is my answer. So this is my answer, right? So okay, let's try to code this thing. So how we can write? I say XOR equals to 0 initially. For I equals 0, I say I is less than n, and I will increment, and I say XOR is equals to XOR of XOR array of 5, right? Given array, and I just return XOR. What I do, I'll return the XOR. Then what will be the time complexity for this? The time complexity will be big of n because we are running only a single loop. We're doing a single iteration, right? This is the time complexity and the space complexity is big O of 1. So this is the optimal solution for finding for finding to represent for finding the number that appears once. So this is the optimal solution. So that will be the time complexity and space complexity for the optimal solution to find the number that appears once and twice. So let us try to understand. Let us try to find the numbers that appears once and other appears twice. So let's start with the better solution. Let us start with the brute force solution first. Okay, brute force solution. Here, if I pick up 1 and I do a linear search, then the one appears twice, right? And I go to this one and I pick up this one and I do a linear search, then this one appears twice. And I go to 2 and I go to 2 and if I do a linear search, then 2 appears once, 2 appears once, right? 2 appears once. And as same, the 3 appears twice and 4 appears twice, right? So 2 appears once. So let's try to do this. I say I'll take a loop for I equals 0, I less than 1, then I'll increment. I'd say, so let us try to write this thing. So I say counter is equal to counter is 0. Then I write a loop that will be j equals to 0. J is less than n, j plus plus. When I say if here the condition is number is equals to the given number is equals to array of I, right? Okay. So here is array of j is equal to array of j is equal to number. Then I say if array of I is equal to the number, then I say count plus plus. Increase the counter. Okay. If so, when the if the counter is equal to 0, then I say return I. So okay, the time complexity here, the time complexity will be the go of n square because we're using two loops. This is the one loop. This loop will do the linear search, right? That's why the time complexity if we go of n square and the space complexity if we go of 1